We did it. March 23rd. Okay. I just need to confirm that we're live. I mean, I believe you. Why would you lie to me?
Wow.
And I really have no idea how any of this works anymore. I'm just a passenger now. All right. We did a Discord Clubhouse on our channel today. It was fun. Have you used that functionality yet? Anybody? Pamela?
Yes.
I've used it when we had to do Cosmo Quest. I've used it, yeah.
You used that on Cosmo Quest?
When we did the Hangout-a-thon there, that kind of forced me to have Discord. At one point, we were using Discord anyway.
We actually use Discord all the time.
Yeah, yeah.
No, not the Discord.
That's the only interaction I've had with
new
it.
Functionality, this new capability, which is like their version of, I don't know what they call it, but it's their version of Clubhouse.
It's where a few people can talk and everyone else listens. Mm-hmm. Yeah. We tend to be more egalitarian and have so far left everyone's audio turned on. But that's just us.
And does that not turn into cacophony?
No.
No? Good. Yeah. I think our plan is to like coordinate these for like live events, like the Axiom launch or
that's coming right up, yeah.
Yeah, the wet
dress this weekend.
The wet dress rehearsal for SLS, that kind of thing.
There's a lot coming up for this next coming month when we turn the calendar over.
What's coming up next month?
Well, we've got the Axiom launch, like you said, the wet dress launch or the rehearsal, and then they're going to have the spin up to Artemis 1, and it's supposed to be in May still.
Yeah.
And then Capstone launches in May. That's a moon mission as well. So.
And then in theory, Musk said end of May, Starship flies.
Oh, there's another Crew Dragon next week, in addition to Axiom.
Yeah,
that's going to the ISS.
There's no way Starship is flying in May.
Yeah,
there's no way. I mean, we're just living on Musk time. So,
I'll be happy to finally see SLS get off the ground.
Yeah,
we've been chasing that one for a long time.
Our entire career.
That and James Webb, yeah. So James Webb is finally in space now.
Yeah,
so SLS
yeah. I'm trying to think. If you include Constellation, it almost matches. Like, when did he first announce? When did Bush announce Constellation?
Yeah, that was like 2003, 2004, I think.
Yeah, okay, all right.
Yeah, and they did do the Ares 1 launch. That's we all got excited because we're like, oh, there's actually something on the pad. Then they canceled it.
Yeah.
So
was like a solid rocket booster attached to a capsule, wasn't it?
Yeah, it was, and it was suborbital. It didn't even orbit. That was just a test. That, I think, was the equivalent of like one of the shuttle SRBs. Was the same engine, basically. Yeah.
So Carolyn, are you having trouble hearing me?
No, I hear you just fine. I can't hear who you're talking to.
So you can't hear me? Dave?
No.
Huh.
Whoa. Can you hear Chris?
Hello?
Chris?
Hello, can you hear me?
Is that Chris?
Yeah, so for some reason, Dave isn't connecting all the way through to Carolyn, but everyone's coming through live, and Dave's going to everyone except for Carolyn.
So me and Carolyn can't talk.
No, you two aren't allowed to talk to each other. I'm sorry.
Wow, so Carolyn and Dave are in parallel universes. That's so weird. Should one of them leave and come back?
That is strange.
I already did that once.
Well, Dave's turn then.
Dave, you want to try leaving and coming back?
Yeah, I can do that.
Okay.
Let me disconnect. I'll be back.
We can just tell you everything Dave is saying.
Exactly. We'll just lay it on to you.
I want to see an interpretive dance.
Yeah, exactly. Yeah. We'll just change the words, we'll shorten it, etc. Larry King is saying, I'll be happy when Starliner is launched. Place your bets. What do you think? Do you think Starliner's ever going to launch?
No.
Carolyn?
I don't know. I'm hopeful. Let's just put it that way. I really don't know.
Try now. Do you see
All right,
Dave's
I'm back.
return?
Yeah, I can hear you.
Okay.
Hey, that worked.
Weird.
Yeah.
I thought it might be my headset. This is a different headset than I usually use. So that was my next troubleshooting thing.
I'll ask you the question too, Dave, and then we'll go on to the actual show. Will Starliner ever launch?
I think it will launch. I don't know if it's going to go to the moon or Mars. Might be a different question.
Well, not to Moon or Mars, but just to deliver astronauts to the International Space Station, like the CST-100, the Boeing.
They want to do Starlink launches too. Like they want to launch like it's way more than 60 per launch on Starship.
Yeah.
They're going to launch huge batches of them.
Starliner, that's the Boeing.
Oh, Boeing's
crew capsule.
I think they will eventually. I mean, they did a test launch that didn't quite make the ISS a few years ago. I actually saw that here from the rooftop.
Yeah.
Here in Norfolk, it launched right at dawn, so we actually saw it come up the East Coast. But.
All right, let's get started. On that note, hello and welcome to the Weekly Space Hangout for Wednesday, March 30th, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about space lettuce, the most distant star ever seen. Space Force patrolling the moon, ludicrously high-resolution images of the sun, and parts of the Milky Way are older than we expected. Joining me this week, we've got Dave Dickinson. Hey, Dave.
Hey, I'm down to only one smart scope now. I had to. I sent the other one back. So not that I wanted to, but
have you?
Which one?
I had an EV scope from Unistellar. I actually had both that and the Vionis one that's here at the same time. So it was interesting to compare how they operated. So it's Unistellar finally wanted that one back, so I sent it back to him. But I've got this one for a little while.
Could be getting auroras tonight.
Yeah, there was an X-class flare just a few hours ago. The sun is really active. Just the last week, it picked up. And there was, I saw that right before we went on the show. I made a short little animated GIF of it from SDO.
We've got sort of mixed rain and sun right now, so we'll see what happens. Often, if it's like this, when the sun goes down, then the clouds blow out and then it'll clear up. So this could be my night. This could be it.
I haven't seen the KP index go up, but that could change really quick.
Yeah, 7 is the number that we're seeing here.
Yeah, I haven't seen it break storm level yet, but it could really easily. Yeah.
We've got Carolyn Collins-Peterson. Hey, Carolyn.
Hey there. How you doing? You ready? Are you ready for tonight?
I'm ready. Maybe I'll.
Are you going to get anything? That's the question.
Yeah. It's like when you see an aurora, it can be like, oh, there's this like faint little green glow on the horizon. You can only see it if you get your camera going, and then you afterwards the next day, and then times it's just like the sky is on fire, and it's like dancing lights across the entire sky,
I lived in
go ahead. I was going to say down here at 40 degrees north latitude, we're just hoping.
Yeah, you stand a chance where you are.
Maybe
you can get to dark skies, can't you?
Well, I'm up at 9,200 feet, so I'm hoping the altitude. But we also have to wait for the clouds to clear.
Yeah.
I lived in Fairbanks, and aurora were so common that they were actually a nuisance for astrophotography. Like astrophotographers would complain that they were washing their images out.
Oh, great. Oh, it's like full moon. Like, oh, no. There's an aurora again. I'm going to go to bed. All right.
Yeah.
Chris, have you ever seen an aurora?
I'm excited when I see Orion's belt from Manhattan, so no.
That's Chris Carr.
Hello.
Also joining us. Yeah. Yep. It's rough. All right. Now, we're going to be doing the news portion first. We've got an interview that we're going to run for the last 15 minutes because it's pre-recorded. So that's going to be ready to go. So as always, with the pre-recorded interview, we put that one last so that we don't have to like sit around uncomfortably waiting for the interview to finish. So, but before we get into the space news, I just want to give a huge shout out to our good friends of the Weekly Space Hangout crew. Our friends, our fans, our executive producers. They call the shots. If you want this kind of ultimate cosmic power, join the community. Go to wshcrew.space, and they'll give you all the information that you need to be an executive producer of this show. All right, let's get into the news this week. Carolyn, let's talk about space lettuce.
Sure. Yeah. Well, I had sort of an introduction plan that I was going to talk about it because I thought we'd hear about Skylab first, but we're going to hear about Skylab later. But this story kind of crossed my radar this week, and I thought, oh, nobody's going to cover this. And then I looked today, and everybody's got it. But it's about space lettuce, and it's really more about living in space and living and working in space a long time, over long periods of time, and how you can keep astronauts healthy. And we know that astronauts suffer challenges to their health. We've all heard about this. Their eyes can go wonky, their vision, their hearts change, their musculature, and they can shift. Even I think Mark Kelly wrote about how his mental outlook kind of changed while he was on a long-term space mission. It'll be interesting to hear what Mark Van de Hei has to say when he gets back from his landing. Well, they also suffer these forms of bone loss while they're in the microgravity environment, and they can lose, basically they leach out calcium, they lose bone mass. There's another nasty side effect to this, which is the formation of kidney stones, which is probably not something you want to have happen when you're on orbit. And obviously this is something that they really want to avoid. So as you see here, they do exercise a lot to keep their bones strong, to keep their musculature strong. And this is a picture of Sunita Williams, and she's exercising. And I've been told that they have to exercise at least 2 hours a day. Some of them go for 3 or 4. And this really gives them a fighting chance to keep their bones healthy when they're on orbit in these long duration missions. There's also some medical solutions that they can do, which are pretty much dietary solutions, like making sure you get enough calcium, making sure you get vitamin D in your on-orbit diet. On Earth here, you could probably take injections of something called a parathyroid hormone, which is PHT for short, and those slow and halt bone mass loss. So the idea being behind the space lettuce is if you could use this stuff in space, a PHT, on a long-term basis, that would be great. But on a long mission, like say you're going to go to Mars or you're going to go to the moon and be out there for a while, it's really kind of difficult to say you're going to store up enough PTH for a really long journey. So out to Mars and back is several years. So Kevin Yates at the University of California at Davis kind of asked the question, what if astronauts could make their own PTH en route? This is in addition to the dietary supplements and the exercise. Can you make PTH that you could en route to your target and maybe come up with some way to make it injectable so that you could use it while you're on your long-term mission? And if you could even eat it, that would even be better. So there basically would be eating healthy or injecting healthy all the way out to Mars and back. So the short story on this is he decided to see what he could do with parathyroid hormones and lettuce, and he developed what's called a transgenic lettuce. It's a form of space lettuce. I think actually I read that he was playing around with romaine lettuce, so at least it's not kale. And it's genetically modified to provide a fusion of PTH and part of a human antibody protein. So you would inject this into your bloodstream. Well, first of all, you'd grow the lettuce, and we already know we can grow things in space. We've done this on the space station. You can do these on long-term missions. So you have your space garden, you go out there and you grow your transgenic lettuce, and then you figure out some way to extract this PTH from the lettuce, use that to, or if you're lucky, you can make it so that it's edible and you're just basically munching your way to Mars and keeping your bones in good shape.
Right.
So this would mean that they're in good health when they get to Mars, because of course Mars has its own challenges that you have to have good health for.
Yeah, I would prefer the munching the space lettuce than grinding up space lettuce, figuring out a way to chemically sort of pull out the specific enzymes that I need and then injecting it into myself in space.
Yeah, I'm kind of guessing they probably would have a machine that would do this. I mean, to do the actual pulling of the stuff out of the lettuce, and then somehow or another it synthesizes this material that you inject into yourself. I know that there have been experiments on board where they do inject themselves with things. I haven't really followed up that recently, but they have practiced that along with all the other space medicine that they've practiced. This just seemed to me like a much easier way to get your bone health going, along with the vitamin D and the calcium supplements.
I wonder if there's like a space radiation version of that you can eat some space radiation lettuce, and then that'll protect you from the radiation.
Oh, that's a really good point. Actually, what I was thinking of in terms of follow-up or spin-offs would be, is there some way you could grow this here on Earth for people so they don't have to inject themselves? But yeah, Good idea. Yeah.
Because I mean, there are drugs that you can take if you get exposed to radiation. Dave, I'm sure you've got some training in this, didn't you?
Oh, in the military, not so much, really.
No,
like anti-radiation drugs. I that's not anything like, for like nuclear war type radiation. No.
Well, I think there's some iodine tablets that people go out and buy. I know. Mm-hmm. I remember reading that people in Ukraine were buying these in case Putin decided to lob a few. Right. And they were sort of a run on iodine tablets, but I don't know what else they would do.
Yeah, and so I wonder if there's anything you could do dietarily to prevent or to limit the amount of your DNA getting blasted apart by cosmic rays.
Maybe we should write to Kevin and ask him.
Yeah.
Yeah.
Yeah, my guess is not much.
Yeah.
Pamela saying
I just thought this was a. Oh yeah. I just thought it was kind of an interesting story, and I honestly thought nobody was going to pick up on this. And now I did a Google search, and it's like 4 pages of stories about this.
We're working on a story right now as well, so we should probably have it done in the next couple of days. So no, it's definitely gone everywhere.
There's a lot more technical detail to it. I think the biologists in the crowd would probably be able to go and read the paper and find out what's happened. Yeah,
I do like that idea though of possibly having this have some like Earth applications where people who suffer from this loss of bone density here on Earth can just like munch on lettuce rather than having to suffer through injections.
Yeah. And I wonder, like, you said, like, I'll bet you there's a machine that you could use to extract this stuff out of it. But I think, like, that's the problem in space is, like, trying to have a bunch of machines. Like, your body is a machine that's designed to extract various proteins and nutrients out of various substances. And so if there's a way to make this stuff bioaccessible to our bodies, this kind of research, I think, Chris, you're exactly right. This is the kind of research that then has applications back here on Earth. Yeah, you can imagine, like, you can get those like little greenhouse, those little kind of like little gardens you can put on your kitchen table that you
aero gardens.
Basil and stuff. Well, imagine if you could like grow a specific kind of lettuce or whatever, but it is specifically designed for the kinds of whatever kind of health issues you're trying to prevent. That'd be really neat. Yeah, I like that idea a lot.
That's cool. You're eating healthy and getting healthy at the same time. But that was kind of the first thing I thought of was what's the spinoff going to be?
Yeah. So Well, I mean, you think about like smoke detectors, right? Like that they were developed by NASA for the folks on Skylab. This is part of the interview that comes up at the end. That's how I know this is spoiler alert. We talk about smoke detectors, but like that technology was developed so that if there's ever a fire on Skylab, they were paranoid about it. But now we all have that exact same technology in our houses, so the spin-offs are huge. All right, Dave, let's talk about Space Force. Now you wrote that you would have joined Space Force had you if you could.
My stance on Space Force is kind of nuanced because they first said they were going to do it in 2019, 2020, when the idea came out, I was like, well, we don't really need a branch because the Air Force already has Space Command, and I'm really kind of against the redundancy because some more colonels will become generals, but you've also got to copy, like, everything has to be repeated again, like iterated again down to letterhead. There has to be a Space Force theme song. There has to be new uniforms. I thought it was a kind of a waste, but it would be cool to be in Space Force, so I'm kind of torn.
What if they called them Starfleet?
Just to say that you were in Space Force sounds kind of cool. So I have a very nuanced stance on it. I don't think we need it, but I would totally join.
Yeah. So what's Space Force up to?
Yeah, this announcement came just a few months ago that they want to kind of patrol the moon as far as tracking space debris. The moon is about to become a very busy place. We've got the Artemis missions. They want to do crewed missions by probably 2025 now, not so much 2024. There's a lot of missions that are going back as far as landers, orbiters. There's about a dozen missions planned to the moon in and around just this year. So the moon is about to become a very busy place, and coming to find out that we don't know quite where all the space junk out in very high Earth orbit and in solar heliocentric orbit, a lot of that stuff has been lost. This was kind of highlighted back in early March 4th, when we had the booster that we thought was first a SpaceX booster that turned out to be a Chinese from Chang'e 5T1, I believe it was, that hit the far side of the moon. a lot of this stuff that is beyond, we have a pretty good track with radar down here on Earth in low Earth orbit out to geocentric, geostationary orbit. There's a lot of debris out there from the Soviet era and the Apollo era onward that has just been lost track of as far as old boosters, upper stages, hardware. And what Space Force wants to do is put a satellite tracking system, maybe something in orbit, or maybe stationed on the moon even, that could track and kind of keep tally of what's out there and what's going on. And also like as far as meteorite impacts, boosters, like debris, things like that. And they want to do it probably around the time the first boots are on the moon for the projection for Artemis around 2025 is what we're saying. Of course, Artemis 1 is doing the uncrewed launch with the full-up capsule and SLS right now in May of this year. And we're probably going to see an Artemis launch once per year. Maybe next year we'll see Crew. They want to put the capstone Pathfinder mission. Rocket Lab is going to put that up in May as well. For the lunar gateway they want to put around the moon. As far as I can tell, I asked the question when they first put out Gateway, there was one press conference I sat in on. I don't think Gateway is going to be permanently crewed. It sounds like it's going to have expeditions.
Yeah, and the plan is to have it be robotically managed, which is a bit of a big technology. They're going to have to figure this out.
It's going to be more like the way the Chinese do their space station, where they send intermittent expeditions to it rather than like the ISS where it's been permanently crewed and there's always a handoff, but there's always humans on board. So Gateway sounds like when it gets up there by 2023, 2024, I think maybe by 2024. Like I said, it's a little depressing when you look at SLS and Artemis. The cadence of launches is maybe once per year. I mean, Apollo did several launches per year at its height. So it's SLS and the Artemis program, even if they get to the moon by 2025, it's going to be a very wide cadence because, if they got crew, they're going to have to supply them.
You see a lot of people making fun of this story. That they're going to be like, what is there out at the moon? What is the purpose of Space Force out at the moon? But I guess, is the value to learn how to scan space away from the Earth?
Yeah, there's a lot of things out there. The European Space Agency wants to put a network out there called Moonlight. That it's kind of a equivalent of a tracking GPS equivalent of a system out around the moon. What I would like to know, and I haven't quite seen yet, is how accessible are these going to be internationally, as far as if Space Force is the clearinghouse of all the tracking of space junk out there, how much are they going to? They do pretty well NORAD right now with Space Track, sharing internationally what's going on as far as what's being tracked out there. The only thing, of course, they don't put out there is U.S. classified missions. Interestingly enough, they put adversarial classified missions, like Russian classified missions, are out there to track, because we're all out there every time something gets launched. We're tracking these things, trying to see them in the sky and stuff like that. But you see the U.S. classified ones come up as blank placeholders in the catalog. They don't publish those publicly, but there's still people out there that are trying to ferret out where these classified missions are in orbit as well.
Yep.
Wait, is there any legal gray area here, like having Space Force have its presence on the moon? Would that be in some violation of the Outer Space Treaty?
I don't think it's in violation of the Outer Space Treaty per se, but that hasn't legally been addressed. Like I said, as far as if they have a GPS system or a tracking system out there, who's going to be able to? Because there's a lot of private corporations and companies. There's Astrobotics and Intuitive Machines are both private companies that are landing on the moon this year. So there's going to be a lot of privatization of space flight around the moon as well.
Yeah, the Outer Space Treaty is really focused on nuclear weapons.
Nuclear weapons in space, yeah.
So
don't detonate nukes in space.
Yeah, so don't do any tests on the moon. Don't put any nukes into orbit around the moon. Don't put any nukes into orbit around the Earth. Don't have any nuclear-powered super space soldiers. But having a military, there are many military payloads that are orbiting the Earth right now.
Yeah, it's ironic. If you track launches, you come to realize that for every scientific mission that goes up, there's maybe 5 military flights of spy satellites and whatnot. That's we've kind of de facto militarized space. I mean, there's no weapons up there per se pointing back at us, but there is a lot of surveillance in military connected tracking launches. I've come to realize it's like, there's a whole lot more military launches than scientific ones.
Space is as militarized as is possible as permitted by international treaty at this point. So, all right, Chris, let's talk about the Milky Way. Parts of it older than previously believed.
Yeah, so I want to bring to our attention an interesting new wrinkle in the history of the Milky Way, which may push the origins of our stellar disk much further into the past. So our galaxy can be broadly split into a few different components. So we have like the stellar halo, which is composed of like very old and mostly accreted stars from like other galaxies that are out orbiting in the dark matter halo. And then we have the stellar disk, which we can split up even further into a thick and thin disk. So the thin disk contains most of the stars that we see in the night sky, including our sun, and it's this extended, rotationally supported structure of younger stars that you imagine like when you think of a disk galaxy. What you're seeing is the thin disk. But on top of that, that's sort of superimposed. We also have the thick disk. Which is primarily composed of older stars, which are more metal poor, and the thick disk has like a shorter disk scale length, so it doesn't go out as much as the thin disk, and it has a larger vertical scale height, so it's thicker, but it's also thinner, or it doesn't extend out as much as the thin disk. So how exactly you get a thick and thin disk, and how it formed in the Milky Way, and when they formed, are still very active areas of research in the field. And so the authors of this work, they came from the Max Planck Institute in Germany, wanted to determine the ages of the thin and thick disk of the Milky Way, and to understand how and the way that they would get about this is getting better age estimates of the stellar populations that make up each of the galactic components. And so for this work, they used a combination of data using luminosity and positional measurements from Gaia, and data on the chemical composition of these stars from the LAMAST spectroscopic survey from China. So in order to build this catalog of over 250,000 subgiant stars in the Milky Way's thin and thick disk. And so how you get ages of stars, since like the age of a star isn't something you can directly measure, it's something you have to infer from other observables, and one of those observables would be the chemical composition of the star. And the reasons why is because like in the early universe, if the only elements around were primarily hydrogen and helium, and so the larger elements of the late universe that we're all familiar with are the byproducts of the successive generations of star formation, which like as stars die, as supernovae, it can enrich the surrounding interstellar medium, and then the stars that come afterwards that carry those trace elements in them. So therefore, the amount of these trace elements in stars today in the Milky Way can help inform your age estimate, as stars born at early times should have incredibly low elements of heavy elements like iron. So you can feed the luminosity and the chemistry of these stars into these advanced computer models of stellar structure, and then from that model can kind of spit out an age. And so with the age measurements of stars in these different regions, you can start to build up a timeline for the formation of the Milky Way. And the plot you see here is plotting the metallicity, which is on the y-axis, so how much iron do they have, versus the estimated age of these stars in the sample. And so you can clearly see by looking at this plot how there seem to be two sort of clustered locations where we seem to find these stars. And so the older clump, you see, and this seems to be like a clear demarcation around 8 gigayears. So for those stars, for the very old stars that are older than 8 gigayears, these correspond to the thick disk, while the stars on the other side of the 8 gigayears, those that extend to the present day, would be the thin disk. And so, like from this plot, you can see that the thick disk stars like they start emerging very soon after the Big Bang. Like some of the oldest stars in this sample can go back to 800 million years after the Big Bang, and so that pushes the origin.
And yet, like with very metal heavy at that point, even though it's right after the beginning of the universe.
Yeah, and so that really pushes like the origin of star formation in the Milky Way like pretty early on, like right, pretty much close to like the first generations of stars and the buildup of those metals.
Do we think these are second generation, maybe?
Oh yeah, absolutely. It's very hard to this point. There's been no observations of any lingering first generation stars.
Mm-hmm.
Like these are called the sacred POP3 stars, which would be stars that have no metallicity, and they'd only have like the primordial like elements that from the first primordial clouds of star formation. So far there's been no observations of any POP3 stars, and so the stars that we're seeing now that have persisted will likely be some combination of those second, third, and fourth generations of stars. So that's where they've really that's where they have some metals, but not none. Yeah.
That's really interesting. And I'm like, any idea why?
Why what?
Like, why do we have those two clusters? Why do we have these old stars in this very specific region of the galaxy?
So that's really getting back to this question of like, why do we have like a thin and thick disk in the first place? And it really, I think, goes back to the star formation history of the Milky Way, because like the thin disk is supposed to be like a product of like this very like gradual and continuous accretion of gas like onto as it accretes from the hot halo, and then it sort of descends to the galaxy, and then you kind of get this like gradual buildup of the galaxy of the disk. The thick disk is likely connected to like a more like early like tumultuous time in the galactic history where you had like much more chaotic infall of gas at very early times, and so it was very hard for that primitive disk to really settle into some nice like rotated structure, because it's constantly being disrupted by infalling material, and so thus the star formation that it produces is very bursty and clumpy, and so it doesn't really adhere to the thin like rotationally supported structures that you get in later times once that accretion is far more like steady and gradual. If you see the picture I'm forming.
Yeah. That's interesting. I wonder, like, does this give us any insights into like just how the Milky Way came together? Any insights into like, you know, did it accrete bottom up, top down? Does it change that thinking at all, do you think?
Yeah, because like an interesting like wrinkle that must also should be considered is, of course, like the Gaia like sausage and Enceladus merger, which is believed to have happened around like 10 to 11 gig years ago, because this places the formation of the thick disk like before you had the Gaia merger, and it's, I guess, like a very interesting like part of this that's really interesting is that this would mean that the thick disk is older than stars in the stellar halo, which is usually believed to be where you find like some of the oldest stars in any galactic system. So that's an interesting wrinkle in all this that I think really like forces us to really rethink about the Milky Way's formation and perhaps pushing it like further back into the past.
Enceladus sausage is the coolest like primordial galaxy name. Like just it's so random. It's like a random generator created it or something.
Yeah, I don't like it at all. But I can see that we're stuck with it. I almost refuse to say it.
I came across that in research a few weeks ago. As a matter of fact.
Yeah. It's like that that weird aurora that's been given a name, like Bob or Jim or
Steve.
Like that.
Oh, Steve.
That's it.
Yeah, Steve.
Yeah.
Yeah.
No, I won't do it. I want to get more creative than sell it as sausage. I'm going to need something else.
Oh, how do you think I feel? You could be like writing some like official like academic paper. You have to write sausage like 12 times in a paragraph.
You feel like you have to explain why is it even named that every time you have to
Dave,
preface
Dave,
it.
you're good at this. You need to come up with a new name for it, and then we got to make it stick. So this is it. This is your chance. All right, let's move on. Speaking of really distant stars,
right? I'm gonna, just say we should name it Chris's thing or whatever. Chris's galaxy.
Chris's galaxy.
Anyway, yeah. So this story is been all over the news today, and I'm not. I think I got the press release late last night, so I didn't get a chance to read it till this morning. But Hubble has claimed that they have seen image to the most distant star ever. And this is a star that is about 12.9 billion light years away. And they saw it as they were observing a gravitational lens created by a very massive galaxy cluster with here's another thing that needs to be renamed, WHL0137-08, -08. But they named the star something very interesting. It's called Earendel, which I thought was kind of cool. They named it after the elven mariner in Middle Earth and the Silmarillion. He's the one that carries the morning star, the Silmaril. So it's called Earendel or Earendel. And so anyway, they spotted this sort of on the cusp of one of the gravitational caustics in this image. And there's several things that are kind of interesting about this, and I haven't dug into the release yet to really see, exactly what they think is happening here. But this star is sort of a triumph of resolution and distance, because it's we're looking back as far as we can using Hubble, and it is the smallest thing they've been able to resolve at that distance, but they had to use a gravitational lens to get it. Previously, they've only at that distance have been able to resolve things like star clusters. The other thing that's kind of cool about this is it's now a very good candidate for the James Webb Space Telescope to follow up on, because from the data we have here right now, we don't really have anything about its color, its temperature, its composition. Composition would be very interesting because it's probably not a first generation star like we're talking about just a minute ago. It's probably, much younger. But what generation is it in? What population is it in? It is among the earliest stars in the universe, but exactly what is it? Once you figure out that composition, you're going to find out a whole lot more about that epoch of the universe that it's existing in right now, as in the image.
Yeah, being able to see an individual star in a galaxy where light has been traveling, what did you say, 12.9 billion years?
12.9 billion light years.
So less than 800
years.
800 million years after the universe began.
Yeah.
We're seeing this star. And Hubble had to, call in every favor to be able to take this picture. James Webb will do this all day, every day.
Yeah.
Just by accident.
That's what I think is really cool about it. And so it'll be, and I don't know where this falls in Webb's observing campaign. Obviously, it'll show up at some point. But I think this is, just another one of these little keys, little keyhole that we're looking at in the early universe that Hubble has kind of rattled the door, and now we can maybe use James Webb to open that door.
Yeah, really, really cool. All right, Dave, you get the last story. You got about 3 minutes.
Yes, we got a really amazing image from the European Space Agency's Solar Orbiter this month. It just came out this week. It was one of the most high-resolution, full disk. This was done with the extreme ultraviolet imager. It really doesn't do it justice to see it just on the screen like that. It's worth hunting down on the web on the European Space Agency's site. They have a zoomable, scrollable, like full resolution image that you can actually go in on. They did this when the orbiter was right in line between the Earth and the Sun, and there was a reason for that. They wanted the same perspective as the Earthbound and Earth orbiting like SDO and SOHO and these imagers that we have here, so they could kind of compare what the Solar Orbiter was seeing versus Solar Dynamics Observatory and SOHO imager, and it went on to did a perihelion about a third the distance, one of the closest perihelions that its solar orbiter's done thus far this past weekend, about a third the distance between the Earth and the Sun. the primary thing that they want to address with this and the Parker Solar Probe that NASA has out there as well is the coronal heating problem they're looking at. There's a big mystery on the sun. You'd think the sun would be hot toward the center, hot toward the surface, and get cooler as it goes further out. But what they see actually is the sun is cooler on the surface, cool being like 6,000 Celsius or so, relatively cool. But it gets up to millions of degrees Celsius out in the corona. So they don't know what exactly is causing this heating. But Solar Orbiter has these ultraviolet imagers, and what you're seeing there with those 4 different, they can look down and see successive layers and take the sun's temperature further down into the sun. They think what's happening is there's what's called nanoflares that are actually superheating the corona. But until these missions have gone out there, they're hoping to catch this in action more on these perihelion passes. And a solar orbiter is eventually going to give us views of the sun's poles as well. Eventually, once it gets, it does a few more passes by Venus, it's going to get kicked out into a more inclined versus the ecliptic orbit. And we're going to be able to steady some of those areas. But right now is a very auspicious time because solar cycle 25 is really kicking into high gear in earnest, especially this week alone. We're seeing a lot more solar activity. And it seems like solar cycle 25 is behaving ahead of projections right now. So it should be a really active one.
That image is a 9K image.
Yes. It's like, I think they said 10 times more resolution than 4K.
It's 9,000 by 9,000. That's right. It's 9,000 by 9,000 pixels.
Yes.
And so, you can zoom in and zoom in and zoom in.
Yeah, it's worth hunting it down on the ESA site.
Yeah, and it is nicely timed that you've got the Daniel K. Inouye telescope in Hawaii is also imaging the high resolution images taken from Earth. So what a phenomenal time to be observing the sun.
Yeah.
Yeah, it's incredible. All right, well, we're gonna shift over and do the interview portion of the show in a second. And so this is the time when me and the rest of the co-hosts bid adieu, and then we'll shift to past Fraser, who will carry out an interview. Thanks, past Fraser. All right, so Carolyn, what are you working on, and where can people find out more?
Oh, you can find me at thespacewriter.com, and I'm at Spacewriter on Twitter. And right now I'm just doing more research for my book about planets.
Right on. Chris.
Hello, if you're interested in following me, you can follow me on Twitter at TheRealCcar, where I talk about science occasionally.
And the solid sausage.
And solid as sausage.
What are you working on right now?
Oh, I'm going to be starting thesis work this summer, like finally. So I'm officially a doctoral candidate. So
nice,
cool,
right on. If all goes well, when will you defend?
I guess 2025, hopefully.
Right.
Yeah.
Okay. Awesome. Dave.
Frequent contributor, Universe Today, Sky and Telescope. Most active on Twitter of the social medias with, I'm at AstroGuys with the Z, mostly tweeting about what's going on in the sky worldwide. Author of Universe Today's Ultimate Guide to Observing the Cosmos, and also most recently being 2 years ago, our Deep Sky Field Guide. And what I'm working on tomorrow, since it's the last day of the month, I'm doing my big guide for what's going on in April in astronomy for Vaonis telescopes, actually. So,
really cool. Right on. Of course, I'm Universe Today on all the things, so just follow me in all those places. All right. Well, we're going to all bid adieu. Past Fraser is going to take over now and carry through to the end of this episode with a really interesting interview about Skylab. So check that out. But thank you. If Past Fraser will have forgotten to thank everybody. So thanks to my co-hosts. Thank you to everyone watching us both on YouTube and on Twitch. Thanks to all of the moderators. Thanks to Pamela for engineering behind the scenes. And thanks to Nancy Graziano for organizing everything that we do. All right. Thanks, everyone. And we'll see you next week. But don't leave. Past Fraser has a really interesting interview to show you. All right. The question I always ask people, who are you? What do you do?
Well, hi, I'm Dwight Steven-Boniecki. I am a space historian and have recently become a filmmaker. I've made a film about Skylab, which you can see the Lego version behind me, the poster of it behind me as well. Why am I interested in Skylab is more than likely your next question. When I was 10 years old...
I think I suspect the answer, but yeah.
When I was 10 years old, Skylab crashed into my homeland. And as a 10-year-old boy, I thought it was going to just solely crash into my home. So it was always in the back of my mind of what Skylab was. And I wrote a book in 2010 called Live TV from the Moon. And I interviewed extensively a gentleman by the name of Stan LeBar, who was with the Westinghouse television division that developed the camera for Apollo 11. And he was always very proud of what they did on Apollo, but he kept saying to me, no, Skylab is where we really got good with the television. And I'm like, Skylab, the thing that crashed in my homeland? And he's like, yes. And I was lucky enough then to acquire video footage that they sent down from Skylab, and it was on a collection of VHS tapes that were haphazardly all over the place, date-wise and transmission-wise. But luckily they had the slates on the front of them, so I knew the date that they were done. And I put them together, and as I was watching it and putting them in sequential order, that's where I started thinking, wow, they did some really good stuff up there, science in particular.
Right, and people were less interested at the time, so I'm sure not very much of that footage was seen.
That's right. I remember as a young boy, I would have been at the time 4 or 5 years old, I do recall watching snippets on the news in Australia, but nothing that I could put my finger on. That. Yes, I remember vividly seeing that. That's what struck me about the TV that they did. There's a lot of experiments. Mathematics was my weak point in school. And when I was watching the stuff they did in physics as well, when I watched what they were doing, I was like, oh, if I had been able to watch this, it would have made sense to me. Fantastic stuff for kids. And that's a funny thing too with our film. We've noticed a lot of young kids are interested in the film, and it must be due to this sort of thing.
And so what story were you, I guess, you're a documentary filmmaker, so you're not supposed to tell a story, to try to tell a story, but what story did you end up telling?
Well, the title often throws people. They're searching for Skylab, and they think, well, did you go out into the outback in Australia with metal detectors and try and look for it? It's like, no. The title came about because a friend of mine who's a journalist, I was telling him all this great stuff, and he goes, yeah, but what did it actually do for me personally, me as a person? What did Skylab bring me? And that got me thinking. It's like, yeah, what sort of answer would we be searching for? And so we came up with the name Searching for Skylab to sort of find the meaning, find the reason why it was up there. What did it do for us? How did it influence the way we live? And basically searching for the place that Skylab has in the way we live today. And reclaiming its rightful place. It's like you were saying, people weren't that interested in it. It was like it fell in the shadow of Apollo and therefore was no longer interesting because you're not going to land on the moon, you're orbiting in space. And what's exciting about that?
Yeah. And so what did you find? When
well, there's a lot of things. For example, little things where you just go, "Wee, I didn't know that." Smoke detectors that we have in our homes, or TV dinners. These things are the direct result of what was developed for Skylab, and it's like, wow, no one in a million years, I think, would have thought that nearly every household would have a smoke detector, and these are things that were developed for that space station, so that they would know immediately if there was a fire on board. The TV dinners, that to feed the men that were up there for the 28, 59 and 84 days, they would need to come up with an efficient food system, a way of serving it, a way of heating it. And this sort of thing carried on into the way we live. And I think for me, that was... yeah, well, look, I can tell you, I work night shift and so forth, and I can tell you sometimes those TV dinners, they certainly do come in handy.
Yeah.
I think for me, the biggest revelation, I always felt, partly due to what I experienced as a child when it crashed into Australia, I always felt Skylab was a failure, purely for the fact that it deorbited and crashed. And that was the most recent 180-degree turnaround in my thinking that I had about Skylab. And that was when we interviewed Mark Pestana, who was a NORAD analyst and was seeing Skylab come up on the decay list and was helping NASA try and determine where and how and why it was crashing. And I said, well, weren't you really upset that this thing crashed? And he goes, no, you have no idea. It set the benchmark for knowing how to deal with a large object re-entering Earth's atmosphere. I sat there, this is during the interview, and I just went, whoa, okay, yeah. I never thought about that. That, I think, has gone on to be very helpful in every single space object that's crashed back to Earth since 1979.
We've had a few more of those happen now. Every couple of years, some spacecraft, satellite, space station returns to Earth in an uncontrolled fashion. It's not going into the Great Pacific Garbage Patch, the graveyard, the Great Pacific Graveyard for spacecraft. It's going to come down in a random location, and everyone is sort of calculating the chances and are you on the orbital path and so on. But this was sort of like the first time when the whole world learned about this mission because it was going to be coming down in a random location around the planet.
Do you remember the TV hysteria from '79? Are you old enough to remember?
Oh, I was like 8. So no, I don't remember Skylab originally at all, actually. It's funny.
Oh, because they went, in Australia especially, because we were part of the footprint that could possibly be in the landing zone. And they went ballistic every night. You know, I went to bed on July 11th terrified because we're ahead in the time zones. And I remember waking up hugely relieved that it didn't strike our house. And I remember they had I think it was the Miss Universe competition that was held in Perth I think it was either late July or August of '79. And that was the first time that they brought to public view a relic of Skylab. And that was the highlight of that show. And that was the first time we all saw this piece of Skylab. And somebody had actually filmed it with a Super 8 camera when it came back down. So that was also the first images we saw of it crashing. It was like a huge media deal. I remember that much.
Now you talk about, searching for the meaning and its impact on our lives, but it did hit the ground. It did hit Australia. So talk about the search for the actual physical remains of Skylab. How much made it back down to Earth?
Quite a bit. It was intended to crash solely, like you were just saying, in the graveyard section of the Indian Ocean. And what had happened, that by a slight miscalculation of the projected, incline, it actually bounced on the atmosphere and flew a bit further than first predicted. And at midnight, Western Australia time, the radios had announced, and NORAD had also announced that it had crashed into the Indian Ocean. So everyone went to bed thinking, okay, danger's over, nothing to worry about. And I interviewed some people who lived in Esperance, and they said, and at 12:30, we heard several sonic booms. We've heard this shrapnel coming down on tin roofs and so forth. And they said, we thought World War III had started because we didn't know what was going on. They were seeing the streaks of debris flying through the air. And then it was like, wait a second, this has to be Skylab, right? And there was one farmer who's in the film. He was working on his tractor in the middle of the night, servicing his fields. And he said he looked up and he saw this thing about the size of a basketball and it was coming straight at him. And he was like, where do I go? He thought the only thing safe to do was dive under the tractor. And he said it got to about 10 degrees above him and exploded in this massive fireball. You can imagine, in the middle of the night, you see this, and then seconds later, you'd hear multiple sonic booms. It was quite a spectacular sight from the people I spoke to who actually saw it come crashing down. two individuals were telling me they were around about my age, so say around about 10, 12 years old, and they said on the beach the next morning there was all this fiberglass that had washed ashore. And for them it was just like, oh, what's this? And they were chucking it out. But I showed the movie there for the 40th anniversary, and every second person in the theatre, there were 300 people who came to watch the film, they would come with this little bag, open it up and say, here, this is what I found. This is what I found.
Wow.
And the thing that impressed me the most, and you see this in the Esperance Museum, the electronics and the wiring in some of the stuff that survived is so robust, it's not funny. This stuff, you could probably still plug it in and use it.
Yep. And it survived decelerating from orbital velocity through the atmosphere and crashed into the ground in Australia, and yet it still survived. It shows like when the International Space Station comes down, it's going to be just very dramatic. I mean, hopefully it's going to go down in exactly the right spot and not crash into Australia, but
no. See, because then we get to claim rightful ownership of it. And right. Well, I'll have to. I do have something I'd like to show you. Sorry about that. That would be a jump cut.
So what is this?
It is a piece of insulation from Skylab.
Oh, wow. Right. So if it does crash into your territory, then you can sell the souvenirs.
That's right.
Well, I don't know if you know, we have something similar in Canada. We have a crashed Soviet era nuclear reactor. So the Soviets launched a few fission reactors on satellites, and one of them crashed into Canada, and they haven't cleaned it up. And so we've got a big chunk of Canada. I mean, not a huge chunk, where you have to be really careful moving into that region, and there's warnings that you can't, that there's nuclear waste on the ground. And it's, so good thing Skylab didn't have a nuclear reactor on board. That could be tricky.
True. Yeah. I mean, there are speculations, and I fully believe the people that told me this, that there is still stuff out there in the desert. But if you,
of course, there has to be. Yeah. You just head out there with a metal detector and see what you can find and plug in and still use. So you shot the film back, or released the film a couple of years ago. What are you working on now?
Trying to sell the film. That's what I'm working on. It's very difficult as an independent filmmaker to get people to take you seriously and to be interested. Most big Hollywood films have a ton of money behind them. When you do something on a shoestring budget, it's a lot more difficult. What we've been doing since the pandemic hit is we've been doing the film festival circuit, and we've actually won near on 30 awards for the film, ranging from US, Britain, Australia, Europe. It's actually been quite successful in that regard. We just need to get the word out to have a couple more people.
Here you go. You're going to get the weekly Space Hangout bump. If people do want to watch it now, where can they see it?
We have it available for streaming on Vimeo.
Okay.
If your viewers would like to get a discount, they can use the password Skylab ATM, and that'll give them a 20% discount.
Perfect.
Skylab with a capital S and ATM capital. And then we also have Blu-rays and DVDs. If they go to our website, www.searchingforskylab.com, they can get all the information, also the books that I was telling you about earlier as well. Yep. I've done the mission reports for Skylab. It's like a long history that first started with me writing about the TV cameras on Apollo that led me to Skylab, and it just sort of fell into my lap. And the funny thing is, for 45 years, just no one had the desire or the inclination to do anything about Skylab, precisely because it was a forgotten era of NASA that people just didn't think it was important enough.
Yeah.
And along comes me and gets obsessed about it. And of course, look at the room behind me. There's no indication that I like Skylab at all. Yeah. Lego
and astronaut suits and everything. Well, Dwight, congratulations on completing the movie. Good luck with finding. I'm sure we'll see it streaming on Netflix or Prime or Disney Plus any day now. But thank you for coming and chatting with us today, and good luck.
Thank you so much for your
All right, take
time. It's been great being on the show. Thank you.